And let's get on to the topic of today's lecture, and it's the idea of how to measure the impact on welfare. And we discussed last class this idea about welfare and how it is the way in which we can measure or estimate it or calculate the basically how does something, it could be a policy decision like a tax, or when the government urges firms to close for something like this health crisis, or a business decision, which is a very typical one of introducing a new product into a market in which you were not part of before, or because you are deciding to basically buy out another firm, and you're basically going to start to operate in this new market, and you're going to put this product, and you're thinking about the price and stuff like that of your product. We've seen all the cost functions. How does it affect consumers? And the idea is, if it affects them positively, they will probably become your clients or your customers. If it affects them negatively, well, they will stop buying your product. And this, again, has very different implications. And essentially, this is what we do when we measure welfare, as a way of placing monetary units into the impact of a business or a policy decision that affects or involves markets. And essentially, a simple way that we have seen how to measure the welfare of people that we saw in the first third of this class was this idea of using utility or utility functions to model a consumer's preferences with regards to different goods, if they were cup douglas or perfect complements or stuff like that. But the problem is that utility, when you remember, you were doing these type of equations and finding the optimal consumption bundle, and the idea of those exercises was finding the optimal combination of goods that this person would want to buy. But if you plugged in back into the original equation that optimal consumption bundle, it would just give you a random number. And when I mean a random number, it would basically give you the correct number for that particular equation with regards to the units you are inputting. But the problem with that is that having a 5.3 utility doesn't tell you anything. And it's really hard to measure welfare that way because we have no idea what a 5.4 or a 5.35 type utility means in real life. Because not only people are different, and a utility function that affects Diego for the same type of behavior, same type of products, is not the same type of utility function that would affect Nicole. So obviously, it's really hard to compare between people because you have this idea of like apples and oranges, and what you want as a firm is to understand actually not in apples and oranges or in people's preferences, but in actual money. How does it affect people positively, negatively, and how, in consequence, that will affect us? So what we tend to do instead, and it's the basis of this class, is basically we measured welfare in terms of the surplus of the consumer or the surplus of the producer, depending on which one we are analyzing. And it is a much simpler way of understanding because the consumer surplus or the producer surplus is measured in real units, basically in money. So we can really easily understand how much the effect of a tax policy is on, for example, the consumers, or how much this or that, a minimum price, like a minimum wage, how does it affect firms? You can actually calculate the effect in terms of money. So we use this to basically try to understand. So basically, the consumer surplus is essentially just the area under the consumer's demand, but above the price. So let's think a little bit what this means, and it's a little bit the idea in the second bullet of this slide. Let's look at this graph. The area above the price, but below the demand curve. This shaded red area is the consumer surplus of this particular consumer of this particular good, whatever this good is. You can model any good this way, you can model any consumer this way. And the idea of the consumer surplus is actually really straightforward once we decompose what the consumer surplus means. So think of it this way. The demand curve, that diagonal line that descends from the left-hand side of the slide to the right-hand side of the graph, is the demand curve. It's downward sloping. We saw last class and since the beginning of this course that because of the law of the demand, as the price of a good decreases, you probably buy more units when it's an ordinary good. It becomes easier to buy more units of that good. And if you like that good, you have preferences, positive preferences for it, you can buy more of them. That's basically the law of the demand. So that's why it's downward sloping. So each point at that, basically at the demand curve, as you move from left to right on your graph or on the graph, you see the willingness to pay of consumers. This is a key concept that it's really important that you grasp and that you basically take when you finish my course and you go to your real life, that you understand that the demand for some good is the equivalent of saying, what is the willingness to pay of consumers, ex-consumers, the Mexico City consumers, the Europe region consumers, the whatever, like whatever is your market, which you're thinking, your target market, what is the willingness to pay of those consumers for my product or for this product? And there are many different types of consumers. You have consumers that are only willing to pay a small amount of money for this good because they don't like it as much. And then you have other people who are really, really appreciative of your good or of this particular product, and they would be willing to buy or pay, sorry, you would be willing to pay a lot of money. Maybe, as we discussed in the first part of this course, it would be because it's one of these inelastic type goods that are really necessary, like insulin or like certain medicines. Like, for example, if there was a new medicine for COVID and some, I don't know, a family member had it, probably most of you would be willing to pay a lot of money to get that like miraculous medicine that would be willing or would be able to cure your relative. So the willingness to pay changes within because of your preferences, because of different things that affect the way you behave, your environment, but obviously they change with the price. So if this is the demand curve and basically your willingness to pay for this good, at every one of these points, this was the willingness to pay. But if we go literally vertically down to the price, this is the point I actually paid. So this difference, imagine that's a straight line. That difference is this surplus. Basically, the consumer surplus is this difference between what I was willing to pay at the basically at the point where the demand curve is and what I actually had to pay. And because this difference is positive and it increases with every single unit I buy, I am better off because of this. This is money that I saved that I could use or resource that I can use for other things. So basically, I am better off. And this is the idea of the consumer surplus. And that is why when we have competitive markets, you maximize this difference because the price you see for the products in competitive markets tend to be smaller, closer to the marginal cost. And therefore, probably the difference becomes bigger. So essentially, we've seen the consumer surplus. We've seen that this is the difference between the willingness to pay of a customer versus what they actually had to pay. And if this difference is positive, they have a positive consumer surplus. So the idea is, how do we measure what happens when we have a price change because of a business decision or because of a policy decision? So imagine that this was the original, basically, consumer surplus, just as the one we saw 2 slides ago. This is the origin type situation. And there is a business decision in which the management of the firm will increase the price of this good for whatever the reason. So if they increase the price of the good, basically the green line that describes basically the level of this price, P1 prime, will increase to P1 double prime. So now you have a higher price. And because of the law of the demand, we know that customers, as they face a higher price, they will buy less units of that. That is the substitution effect. You will move towards other type of goods or other types of brands from the same type of good, but you will basically stop buying some of that product. So in this case, the original quantity being bought and demanded was X1 prime, and as the price increased, now you move to X1 double prime. And as you see, the triangle that measures the consumer surplus is smaller than it was before. And we can basically calculate the size of the triangle and the actual units of the triangle very simply. We have, imagine that instead of the P1 prime and the P1 double prime, you literally place numbers. Let's say P1 prime is 5 and P1 double prime is 10, 10 pesos. And the X1 prime was, for simplicity of the calculations, it was 10 units, and now X1 double prime is 5 units. So you've passed from buying 10 units to 5 units, and you've passed from paying for each of those 5 units a smaller price. So if we do this calculation, if we actually calculate the size of the consumer surplus, we can see that that is a smaller triangle. Let's say that in the original case, the units being bought were not 10, but they were 11 units. X1 prime is 11 units actually at that same price of 5. So let me try to write on the slide. Let's say C of S prime. This is why I don't use an iPad. As you can see, it's really hard to understand my writing. If we wanted to calculate the original triangle from before, imagine that this is a straight line. If we wanted to calculate this triangle from before and what was the consumer surplus, well, we would see how many units I bought, X1 prime, and we said that that was 11 units, times the difference from the maximum price you were willing to pay, this point here at the top where the demand starts, and what you actually had to pay. So because we don't have numbers and we're inventing them right now, imagine that this vertical difference between P1 prime and the top of the demand was 10 pesos. That was the difference between what you were willing to pay for this unit and the actual price. So it was 10 pesos, which would be 110, and the area, you have to divide that by 2. So we see that the original consumer surplus would be 110 divided by 2, which equals 55. In monetary terms, 55 pesos would be this person's consumer surplus for this particular good. But now, and I'm going to write this in another color, red color. So now, after the increase in price, we need to calculate a new consumer surplus. And this new consumer surplus is this new triangle, which is smaller, as you obviously can see. So how are consumers now? Now they're buying X1 double prime. We said that was 5 units. And now the difference between the maximum price here, what that you were willing to pay, and the actual price you paid is smaller. Let's say this is now 5 units, 5 pesos instead of 10 pesos, which was the other difference. If we divide that by 2, we have 25 divided by 2, which equals 12.5. And if we compare the 12.5 consumer surplus, my numbers are terrible, sorry, the handwriting, it's really hard, versus the original consumer surplus of 55, you can see that this person is much worse off. This consumer is much worse off buying this product this time than what it was before. So because of this, they will most likely try to buy another good, a competitor brand, or literally a substitute of this good, if you're thinking of an input or something for your production process. And this happens because the monetary gains of the, let's call them, of the savings, of the imaginary savings of this product became much smaller. And this is why when you decide to increase the price of a good that your firm produces, you need to understand how it will affect your customers. It will undoubtedly reduce the number of customers as it passes from X1 prime to X1 double prime, but also it decreases the consumer surplus they have. And therefore, depending on how big that difference is between the original triangle and the new triangle, they will be more determined to change your product or change from your brand. Questions on what the consumer surplus means and how do you calculate the consumer surplus. Anyway, basically, this is what we just calculated, the lost consumer surplus. We actually gave them numbers. We did a simple example to understand this. Let me go over this quickly. This example, you can see later on in when you need to study for this. So we can estimate the demand of many different things in real life through different mechanisms. But for the sake of this equation of this problem, let's suppose the demand function for parking meter spaces in a city like Chicago, where I used to study, is modeled or can be modeled by this equation X, where X is the quantity demanded of spaces, equals 115 minus 65 times the price of the parking meter, PX. And basically, we want to understand what happens to consumers, the consumer surplus, when the government, the city government, decides to increase the per hour price, the price of the parking meter per hour, from 75 cents to $1. This is something that the government is calculating when they are trying to decide if this should be an adequate policy. So this would be like, not to scale, but this would be like the triangle or like the graph of the demand curve of the literally the one we were graphing here. Uh, as you can see, this is the maximum. This is in terms. This is the actual demand curve. And remember that when you want to graph them, you need to invert the demand curve and isolate the price. P equals something with regards to X or to Q, as we do the graph, because we have P in the y-axis. So once we invert the demand curve, as we saw at the beginning of this course, we get this graph. And those are the numbers for the different things. So right now, the price is 75 cents per hour. And at this price, basically 66.7 whatever million, thousand, let's say it's thousand. There are 66,000 cars being parked, basically. Almost 67,000 cars being parked at this price. So what happens when the government decides to increase the price from 75 cents to $1? So obviously, less people will be able or will be willing to pay the per hour price of parking on the streets. So instead of having 66,000 cars being parked at the same time on the streets, now you only have something like 50,000 cars at this price. So obviously, the new triangle, this black one, is smaller than the one that is created by the green bar below. So what we want to do is estimate the impact on welfare for consumers. Now we have everything we need. We have the maximum price that this consumers would be willing to pay, which would be $1.77 per hour of parking meter. We have the prices, $1.75 that we had the policy, and we have how many cars will be parked at those prices. So we calculate this area shaded in red of the original the original situation. And as we see, the area of the triangle is, well, how many units? We have 66.7 units. And the difference in the maximum price with the price we're actually paying is 1.77 minus 75 cents. That is $1.02 of surplus. It's called like that. And the 0.5 is from the formula, from the triangle area formula. And we get that the consumer surplus is $34 per customer or per consumer of consumer surplus. This triangle is basically worth $34. So now with the new price, we calculate the new blue triangle, in which it's obviously smaller. And as you can see from the formula and the calculations, you can do them on your own later on. You have a smaller triangle that now only represents $19.25 instead of the original 34. So essentially, this policy decision affects consumers, and the lost consumer surplus is this orange trapezoid that now we don't have. And you can also calculate that, and that calculation is the difference between both triangles, which in this case is that consumers lost $14, and almost $15 because of this policy decision. Question before we finish today's class.